Okay, hello from my side. Thanks for coming here tonight, to this topic, Duel of the Giants, Entity Framework versus Entity Framework Core. Sounds like a little blockbuster in the cinema. Hopefully everybody is feeling like that tonight. As I already have been introduced, my name is Gießwein. I'm from Austria. I'm coming from the Alps. Nearly 1.5 hours driving me to come to Munich today, and it's a pleasure for me to do a talk again in Munich, because the last talk of my one was at the .NET User Group 2014, so it's 5 years ago, and I didn't recognize that the meetup was involved out of this user group, and it's a pleasure for me to be here invited and to talk about this topic. To my person, what I'm loving and what I'm doing, I'm a .NET developer for years now, and that's the topic which I really loves. And I'm developing much with databases, and therefore I have to work with Entity Framework, and of course I have to touch Entity Framework Core because it's the new train on the rails, and therefore I want to talk a little bit about what's the difference between Entity Framework and Entity Framework Core. Just for me, just a little hindsight, who is a .NET developer? Hopefully everyone, nearly. Who has done something with Entity Framework before? Okay, and who is doing something nowadays with Entity Framework Core already? Oh, that's really a few one. So I'm going into a little introduction into Entity Framework overall, and we will deep dive into the topic afterwards. Basically, as it's usual for me, I do not make any presentation with PowerPoint. So we will have a look with Visual Studio, we will code directly, and I will show you some examples how things work nowadays in comparison to Entity Framework. What do we do nowadays with Entity Framework Core, and especially what are the benefits out of it if you use Entity Framework Core nowadays, because it is the new direction, it is the future of the current OR mapper of Microsoft. So, what is Entity Framework about? Just to shorten that up. If you nowadays are working with a database, for example, and you want to connect to the database and sum up some data from it, you want to retrieve some data, you want to change some data, you want to delete something, so you have to do the common CRUD scenarios with your database. You can use and utilize Entity Framework, for example. It is one framework which is nowadays some years old, and Microsoft said, okay, that's a good framework we want to use, but they have introduced a new framework, Entity Framework Core. Entity Framework Core is completely a separate thing. That's important to understand at the beginning. So you have Entity Framework and you have Entity Framework Core. The name is slightly the same, but the core makes the difference. The core means they have looked at Entity Framework and said, oh cool, that's a nice little framework. We have several versions of Entity Framework and several companies and developers are using it. It had some special things which are working very good. But they'll have looked at it and said, okay, we made some major, I don't want to say problems, but some major things what they don't like. And afterwards they said, okay, well, let's do it again. We will start from scratch again. So they had a new project. They named it initially Entity Framework 7, because they said, okay, the latest version of Entity Framework was 6 or is 6, and just named it Entity Framework 7. But at the end they said, okay, moment, we did a complete rewrite of the whole code, of the whole technique, and afterwards they said, okay, we name it Entity Framework Core. If you look at today, Entity Framework 6, the old version, old is not the nicest one, but it's the old version, was one of the first frameworks of Microsoft which they did open sourced. So you could have dug into the code of Entity Framework several years ago, in the past on the platform Codeplex. Nowadays you can look at the code at GitHub. like every other framework which Microsoft is developing. Entity Framework Core itself is at least like Entity Framework also on GitHub. So we have to clear one thing in addition. We have the .NET Framework and we have .NET Core. They are two completely different engines. So we are talking about different runtimes. And in Entity Framework Core, the name Core is appearing. But if you look at it, it has nothing to do with .NET Core. Just the naming is a little bit confusing in my opinion. Entity Framework Core you can use with the .NET Framework as you can with .NET Core. So you can mix that up if you want to. We will have a look why this is. So just to start with that. If you nowadays look for Entity Framework, you get two repositories on the GitHub page. First one, this one. Yeah. So these are these two repositories which you get nowadays with the Entity Framework 6 and the Entity Framework Core. They are completely separated repositories out of the history that you say, okay, we did a complete rewrite, we did a complete new start with this framework at all. You see it already here because the old one, the Entity Framework 6 version, has only about 2,000 commits with, in comparison to the Entity Framework 1 with more than 7,000 commits. If you look at a little bit more about the history, you will see that this one is really an older one, and the white one is much more a newer one, which is much more getting much more features than the old one. So you have to understand that this is two completely different things. If you look at this, we will start with a little sample so we can see what the comparison is and what the difference is. To do that, we have to think about how we can get started with that. Entity Framework, it isn't matter if you talk about the 6th version or the core version. Entity Framework at all. You have to have a database which you want to communicate. You can create your database from scratch on your own. You can create some SQL scripts and say, I want to create a database, DemoDB, and I want to create a table, create table, and so on. You can create all the SQL statements on your own. And afterwards, you come with the framework and say, I want to connect to the database. I want to use this database within my .NET Framework project. That's one way. So you create the database first, and afterwards you are creating the model in your code. That's one way. The other way is you don't have any database at all. You create just your code which you want to utilize. You create, for example, a little class which is modeling. I want to save some data, and this data is represented with property A, property B, property C, and so on. And afterwards you say, you throw this class into the Entity Framework and say, just create a database for me. And Entity Framework will do that for you. And one special thing is, and that's already one of the biggest differences between these two, Entity Framework 6 was a classical Microsoft framework. That means Entity Framework 6 is very good if you're utilizing and connecting to a Microsoft SQL Server, for example, because this framework is always getting delivered with the MS SQL dependency. You don't have to utilize it, but you get it. And other vendors are getting invited, okay, if you want to, we have a possibility here to connect another database. So for example, Oracle created a provider on its own and said, okay, we have an additional provider for Entity Framework 6 and you can utilize Entity Framework to connect to an Oracle database. That's nearly fine. But it's not that easy because Microsoft said, okay, we are Microsoft, we want that you use Microsoft technology at all. And this thing has changed a lot. Entity Framework Core, Microsoft said, oh, yes, of course, we have a Microsoft SQL Server. Of course, you can connect to it, but we know that we are not the only vendor of database engines. So if you want to connect to another database, you are open to that, and we change the way to connect to another database dramatically. So it's much more open, this one, the core version, depending on the target system you want. And at all, Microsoft says nowadays, yeah, of course, we are delivering a provider for a Microsoft SQL database, but not only Microsoft SQL database. In addition, we want that someone is utilizing, for example, Entity Framework Core to create a mobile application. You can utilize Entity Framework Core, for example, with Xamarin. You are developing with the Mono engine, with the Mono runtime. You're utilizing Entity Framework Core and you say, okay, I want to connect to a database, but normally you don't want to connect from a mobile phone to a Microsoft SQL server. You want to have a local database, and especially a SQLite database, for example. So Microsoft says, okay, we deliver already a finished provider for SQLite, for example, and that is coming from Microsoft. But the database of the SQLite database isn't Microsoft. So they opened that and said, okay, we are open to any database system here, and we're providing an easy way to connect it. And that wasn't this old-fashioned way, a very hard way to do that. Let's have a look. I want to create a little project here, so I'm opening just, for example, my new Visual Studio 2019 here. And we will create a new project. Console application would satisfy it all. I utilize a .NET Framework console application now, just to ensure that we can use .NET Framework as we would do with .NET Core. We name that Meetup Munich AF, just to have some code to do that. Some hours later. Yes. Yeah, some updates. My subscription is not valid. I don't know why, but we'll solve that later. Okay. To get this thing started, you have now to install your dependencies and say, okay, I want to connect to a database with EF Core or EF6, for example. And especially at this nowadays, you have to use NuGet to get the packages right you want to use afterwards. In the past, it was really, really simple to install Entity Framework because you just have to select here the lookup tab, and instantly you will get Entity Framework here. And it's important here to have a look at the package name especially, because Entity Framework means that's the old one. The old one which is getting recommended instantly, just because it is one of the most downloaded packages at all at NuGet page. We have nearly 61 million downloads here. And if you click at it, you will get the old 6 version here. Here you can see at all that this version is coming out of 2017. 2017. That means this package is more than 2 years old, and we will get a new version this year for Entity Framework. Just to mention that also, because we will get a 6.3 version this year. This version will not bring any new features to this framework. What will this update bring to us? We will get .NET Core 3.0, that's the new version of it. And with .NET Core 3.0, we are supporting WPF and Windows Forms application. And Microsoft said, okay, we will get .NET Core 3.0 with desktop support, and we will support legacy applications nowadays. And if we support them, most of the legacy applications, if we look at applications which are maybe 10 years old, which are using Windows Forms, will likely utilize Entity Framework 6. But Entity Framework 6 is not compatible with .NET Core. It is compatible with .NET Framework, of course, but not with the core version. So to make this bridge coming, they say, okay, you can convert a legacy project into the direction of .NET Core 3.0, you can update to the upcoming version 6.3 because the 6.3 version of the entity framework of the old one will be supported on .NET Core 3.0. So they are making a little bridge version with no new features, that just to ensure that every legacy project has a way to get to the .NET Core 3.0 version. If we talk about that, that's, in my opinion, a sentence that will sum up that the .NET Framework at all has not a large future in my eyes. If I look at this, I would say .NET Core is the new future. We have to convert in the next months, in the next years, every .NET Framework project in the direction of .NET Core. Because this is the last thing which is missing out in the new world of .NET Core. So you can create web applications, you can create any services, you can create legacy desktop applications with the Windows Forms or WPF, and you can utilize old OMAP like Entity Framework, for example. If you want to use this one, we have just to ensure that this package is getting installed. If we install Entity Framework, so this means this little one package, this little one, you will get two libraries, you get two assemblies. One is the Entity Framework assembly at all, and you get always the Entity Framework Microsoft SQL Server dependency. You get this DLL, you will get at every time you will utilize Entity Framework. It is nevertheless, if you connect into an Oracle DB, MySQL DB or whatever. If we change that and we want to use Entity Framework Core, we have to look up for Microsoft.Entity Framework Core. It's likely to get this one. That's now the Entity Framework Core version. We can install this one. And one thing has changed. They say, okay, Entity Framework Core is a framework to talk to any type of database. And they designed the whole framework a little bit more with aspects of modularity. And they said, okay, we have some plugins, we have some possibilities to talk to any database. To any database means for Microsoft, we have the base packages, Entity Framework Core, and the first little specialized package is, for instance, the relational package here. That means this package is not possible to talk to any relational database. It is just the base classes which are needed for describing something with Entity Framework. And as soon as we install the relational package, we will get the possibility to talk to something relational. But something means we are not database system dependent. We don't specialize to any vendor. We say we just want to talk to any relational database. If you want to go more special, we have to decide which database. And this is the next one. For example, in this entry here with the SQL Server. We have here the SQL Server entry, which means, hey, we want to talk to Microsoft SQL Server in this case. So we decide which target database we have at the point when we install the package. And we will see this on the right side because here it states the dependencies of this package. And these dependencies are, at first, the system data SQL client. That means we want to use the SQL client out of the HDO.NET framework. We want to talk to a Microsoft SQL server. In addition, we get the dependency to the relational package because the Microsoft SQL Server is a relational database. And the third dependency, and it's an important one, is we need the .NET Standard. The .NET Standard, at least with a version 2.0. That means .NET Standard is the possibility for us that we can utilize Entity Framework Core nowadays with .NET Framework, .NET Core, Mono, Xamarin, and so on. It's specialized and says, okay, it's completely independent from the runtime itself. We want to use Entity Framework Core. It states only, okay, if your runtime supports .NET Standard 2.0, you can use it and you can utilize Entity Framework Core afterwards. For instance, I want to go and say, okay, I want to use a SQL Server nowadays. I just ensure that this one is getting installed. And I'm installing the Microsoft Entity Framework Core.SQL Server now. That means I'm getting the base package, Entity Framework Core, I'm getting the relational package and the SQL Server package with the dependencies to the SQL client database package. And afterwards I'm getting all these assemblies and I can connect them together and say, okay, I want to create now something with Entity Framework. Let's do that, hopefully, after it's getting installed. What do we need? After we have installed all these packages, we're getting some types which we can use now to talk to any database we want. Yes, my life is going to you. The important class of it all in the Entity Framework world is the DB context. And this fact is the same in Entity Framework 6 and in Core. You always have a base type that's called DB context. The DB context type is something like the glowy hole manager, which is saying, okay, I can connect to any kind of database. This DB context lives in both packages. It is the same name. The important thing is the namespace is a little bit different. You can mix up Entity Framework 6 and Core in the same project if you want to. That's also possible. But that means you have to pay very attention about that. If you say, okay, I have the DB context out of the Entity Framework 6 package or an Entity Framework Core package. Let's do that. I'm creating a little class here, my DB context core. Pardon? Can you zoom in? Yeah, of course. Hopefully I can. A little larger. This class has to be derived from the base class, and you say you have to derive from the DB context. And I say, okay, I want to use this one. You're getting here the using statement for Microsoft Entity Framework Core. That means we are using the DB context out of the Entity Framework Core in this example, and afterwards we can utilize this class and make something with that. What is this DB context for? This DB context is describing what is our database look like. What are the entities into this database? Which are the tables we want to get the data from? That means in this case, this context is completely useless. We can't use it because it has no content. We have to add some content. That means we want to add some models here. We want to add some entities. That means in my case, I don't have any database. That's okay for me. I will create this database, or Entity Framework will create a database for me. I have to describe this database and say, okay, what is a table into this database? In my example, I will add a simple property now and say, I want to describe a table which is named person. My person has some simple properties. It has a first name and the last name, for example. And because I'm creating a class now which will be getting mapped on the database, I'm creating something like a primary key. So in this case I would say I want to have a property public int ID. And I say, okay, this ID will be my primary key which is getting saved and stored to the database. This person will be getting added to the context itself. So I'm adding here property public dbz, which is a generic one, and I say that are my persons in my DB context. And that's all. I'm describing here one entity, I'm describing here one table if you want to. I'm adding this one to the context at all, and say, okay, my DB context core has some persons. And afterwards I'm already finished. I can utilize this context now. I can say, I want to let this database getting created, and I want to query this database for some data. To do that, I'm just creating an instance of my new MyDB context core. And one special thing is, if I'm looking at the properties and methods I'm getting here on this little object, and I can do here several things. One thing is I can access these persons. This persons is the entity Z, the DB Z here, that are all my persons which are in this database. I can iterate about these persons with a for each or with link and so on, and the entity framework will do every magic to get this data from the database which is needed for that. But beside that, I have also some properties and some method which is getting derived from the DB context class. And for example, the property database here, which says, okay, you can interact with your database if you want to. In my case, I don't have any database. What I can do here now is I can access the database property and say, I want that I'm ensuring that the database is getting created. So I'm calling just the method ensure created, and afterwards entity framework will check now and see, is this database already existing on the database system, and say, okay, it exists and it does nothing. Or it says, oh, the database doesn't exist, I'm trying to create a database. That means I'm creating the database at all and all the tables which are needed and described in the code for this example. In my example, if I'm starting this one, it will not work. It will not work for the reason because I have not configured the DB context. The DB context doesn't know which database provider has to be used. And that's one major difference. Entity Framework 6 always said, oh, you want to use ensure created. This method has already exists in this latest version. Entity Framework 6 always said, oh, I'm trying to connect to a local MS SQL server. If I don't have one, I'm getting exception which says cannot connect to the MS SQL server on your local host. And that's already a difference here, because Entity Framework Core says, okay, I'm in the default configured, I don't know any provider. You have to say to me which provider you want to use. To do that, you have different possibilities in the Entity Framework Core way. The easiest one for this example would be you could override a method which is named onConfiguring. The onConfiguring method says you can configure this context now, how it should be used. In my example, I say I want to use the options builder, and because I have installed already the Entity Framework Core.SQL Server package, I'm getting an extension method which states use a SQL Server. This use SQL Server method takes in either a connection string or already a DB connection. In my case, the connection string would be fine. So I can just jump in with a connection string here and say, let's use a SQL Server which exists on my system. To get a connection string in this example, I'm just looking it up here in the SQL Server Object Explorer if it wants to come up in my one. Oh, yes. Here it is. I have a local MS SQL Server, I have a local DB here. I'm just creating a new database and name it, that would be my little EF demo. I'm connecting to that one, I'm saying the properties of it, and I'm just copy out the connection string at all, because writing that one down out of my brain is mostly a headache. If I start this example again, it now doesn't complain about I'm not configured, because it is now configured. The console will go up, it will close automatically afterwards, and yeah, nothing happened because everything happened behind the scene. What we have now is not just only a demo database, we have additional some tables within this database now. But some tables a little bit too much. We have one table with the persons with an ID, first name and last name, like we have described here in our class. So that's the database, that's in this case our code, and we can already interact with that. Because I have named the property here ID, it has automatically a convention invented into the Entity Framework Core which says, okay, if you name something like ID, I'm assumed that this one has to be the primary key. If I have named that, for example, number or something else, it couldn't know that this one would be the primary key, so it would have created this table without the primary key. But in this case it has it, and it has created the primary key out of it. Okay, let's get the things a little bit speed up. We have now our database. We can query now with the instance the persons. The persons is the DB set of persons. And the special thing in Entity Framework as in Entity Framework Core is the person is like a list. Like a list, I can add in some persons, I can remove some persons, or for example I can iterate about these persons and I will get it. So all these basic things, reading, updating, deleting and inserting, all these 4 basic scenarios are supported with this list. So I can do, for example, and simple, I want to add a new person, yeah, that one, and I'm throwing in a new person. Entity Framework and Entity Framework Core will say, okay, at some point you have to tell me when do I want to save the changes to the database. It doesn't do that at the moment I'm adding it with the add method here. It says you have to clarify a point at the time you want to save everything. That means I have to call the save changes method at some point of time and say, now I want that every change I made is getting stored in the database. In this example, it stores in the new person and says, okay, I'm inserting that. That means someone has to create the SQL statement for it. It has to state, I want to insert into persons some values. The values are depending on the person. I am filling it up with some data here. That means my first name and my last name, for example. And afterwards I'm just starting the application. It will do again a lookup, is the database created? Yes, it is created, I have nothing to do. And afterwards I will call the save changes and would say, oh, Entity Framework, just take a look, does you have to do anything? And it says, yes, I have to do something, I have to add a new person to the database. And afterwards, if we look at that, we will see that this person is already in the database. That means if I'm just looking up all the database in the table, I will see my one and only data set here, and I will see, oh, okay, the entry has been stored to the database. Okay. To make a little comparison out of Entity Framework and Entity Framework Core, I'm doing now a little crazy thing. I will do that I will install into this project one additional thing. I will install the Entity Framework package in the old version. So I have one project. This project, again, is a .NET Framework project, which has a reference to the Entity Framework 6 version and the core version. I have both packages and both frameworks installed into this package, into this project. So I can utilize any Entity Framework version I want in this project. In my case, I have the DB Context Core. I have named it DB Context Core just to ensure which one this is. Because nowadays I can do something, I can say, I want to create another DB context. I name it my DB context EF6 and I'm deriving again from DB context. In this case, it would be also an Entity Framework's core context. But I can do something special and say I want to take another DB context out of another namespace. I'm picking up the DB context type out of the namespace system data entity, and that's the old one. And that are nearly the same name, but the namespace makes the difference. In this case, it is really an EF6 context. I'm working with the EF6 framework in this example. But what I can do nowadays is I could take this DB set of person, I'm copying that one and say I want to add the DBZ of persons also to my DB context EF6. I have to pay attention again because also the DBZ is defined twice, once in the Entity Framework core version and this one in the Entity Framework 6 version. I have here now the same context with two different DBZs, which are getting connected to the same database. If I want to do the same now, I could do a second one, EF6 instance, and I'm creating my DB context EF6. And I'm saying I want to do, for example, completely the same. Again, I'm saying I want to add a person. I'm calling the save changes method, and I'm just putting out something of the console and say, I'm finished now. The API is nearly the same. I have to derive a DB context, I have the DBZ, I have to add some entities, some instances I want to add, and at some point of time I have to call the method save changes. Everything is the same, nearly. Because if I rerun this example now, I will get a little problem. It will take some time. It will say later words finished. And that's a little bit crazy because if we look at that code again, it would wonder me because I'm not calling ensure created and EF6 is able to store this person now. And in this case, if I look again at the context, I have not overwritten the method on configuring because this method does not exist in EF6. EF6 is a little bit more specialized to Microsoft, as I've already told you. And it says, oh, I have no configuration. Okay, I'm doing my best. I'm guessing a little bit. My first guess is there a local system here with a local database, which is Microsoft? Yes? Okay, I took this one. And we have a look at the database system again. We will see that I have now an additional database which is named Meetup Munich EF my DB context EF6. Because it has found there is a local database. I don't know what's the name of the database, so I'm guessing I'm just taking the type name of the DB context, and that has to be the database name. And because it doesn't exist, I'm creating it. So I'm creating the database, I'm creating the table person, but also person is not that right. If we have a look at it, it's not the person database or the person table, it's the people table. That's a funny fact because I already told you some conventions. The convention is if the property name is ID, it's the primary key. Another convention is in EF6, it's the pluralization. EF6 is trying to pluralize every name you have because that's a nice feature, or I don't know. And it says if someone is creating a DB context with the name person, the table has to be people. The funny fact is, just have a look at the GitHub. There is one really large class with thousands and thousands of lines of code with just a dictionary which is mapping person to people and some other kinds of words from the singular to the plural. And it's a nice convention in EF6 which is in the default enabled. EF core said, oh, that was a stupid idea, we forget about that. That's quite okay. But we don't want that behavior we have nowadays. We don't want a new database, we want to utilize the same database. It should use our EFDemo database with the connection string we have here. To do that, we have to modify just some things. One thing is we have to configure this context now. We have to configure the connection string and say, I want that my DB context EF6 is connecting to our existing database. We have the connection string already here. In the old way, you have two possibilities to configure that. The first one is you can add some configuration to the app config. The beautiful XML file, which mostly nobody knows what you have to write that. There is already here a new section, entity framework, and for example the default connection factory here. And you could add here the connection string. That would be one way. Or you can do it in your existing code. I will do that to see that. You just have to define an own constructor and calling the base constructor of the DB context. And here are an overload for a string, name or connection string. That means name, give me a name. I'm looking in the app config, that's the default. Or you give me the connection string directly and I will use that one. In this case, I'm just make a little copy of my connection string here and say I want to use the same one and calling that one in the base constructor. So we have already half the way. We can utilize now the MyDB context EF6 context and say, okay, we want to connect to this database, and it will use now this connection string with the initial catalog EFDemo, that means our database. But we have a little problem now, because EF Core has created a table with a different name as EF6 would do it. So it would find this database now and would start to create a query for the insert statement, but afterwards the SQL server would say, oh, this won't work because I don't know the table people. I know persons, but not people. So we have to disable either this feature, that could be one possibility, or we have to configure it a little bit. Just to show you how easy it is, we can define that, for example, in this case with an override of the onModel creating method. And the onModel creating means that's the point when EF6 try to create the model, how should the model, the database model, look like? And we can intercept that and say, oh, lovely model builder, I want to configure the entity person, because the entity person is mapped to the table person, and because I'm mapping that now to the table person, the convention is getting ignored. So it's directly connected to our database, like stated in the connection string, and in addition it knows which table to query. And if I'm starting this example again, it will again say, okay, I'm finished. And if we just refresh here this little table, we will see that this isn't working. Oh, okay, someone is sting. Yeah, you are right, because you are sting persons. Yeah. Welcome to hell now, because I have now a little problem. It has looked up the database, it has found the database and say, oh, is there a table named person? No, it isn't, so I'm creating it. I'm just helping myself out. I'm just dropping this one and also this one table. So here are the persons now. Now it will work like expected. And now we will have here our second data row. Okay, perfect. Thanks for the help. That means now we have the same database, the same table, but with two different frameworks. We are connecting from one application, say, okay, how are the things going on? Let's talk a little bit more about the differences now. One interesting thing is, if we just call up a stopwatch for this example, and that's already a thing which I'm really like with that one. I'm just giving out on the console how long this code will take. It's totally simple. It's just state, okay, I want to add a new person. I want to save that. I need one simple SQL statement. And I want to measure that time, how long that takes. What would you estimate? How long should that take? Minutes? Hopefully not. Seconds? Maybe. Milliseconds would be better. If we run this little sample, we will see milliseconds is a good hope, but it isn't. It takes up to 2 seconds just to start this sample up. If I'm exchanging the code and say, okay, I know what the time is which is taking with the EF6 version. With EF6 we needed 2 seconds. What does it take if we say I want to use the same code but now with the core version? Nearly the same. The only thing I have exchanged is now, in this case, is the MyDB context core. And the other case is the EF6 one. And if we rerun this sample, we will see 1.12 seconds now. That's the speed up, in this case, about 50%. Same framework, same types, same API, but EF core to EF6 is a startup, in this case, 50% faster. That's not always the case. It depends a little bit on the use cases. It depends a little bit how complex your model is. So you can't say it's every time that's in that magnitude, but in this case it is really a difference. Why is this taken, or where's the time spent? It's a better question in this case. You have to remind that in our case, if we call the first thing a method on a DB context, some things happens behind the scene. We are calling here save changes. We are accessing my DB context core. It has to create the model. It has to create what are the connecting types, what are the tables, what are existing on the database. So it has to query, does the database exist, does the table exist, and so on. And this takes up some time. This initialization is only done once. That means if I rerun this sample and say, I want not to give that watch out only once, I want to do that twice, for example, or much more often, for example, we will see that the first time it will take some time. One second in this case. And if I'm just pressing enter and do it again, we will do it much more faster. We are nearly by 10 milliseconds, which is quite okay. That's because the model is getting created only once. At the first access, every time we will get this initialization, it will create the model once. It will create, okay, we have a person, that's the primary key, that's the properties of it, and so on. And this takes, at the first time, some time, and afterwards it gets stored in memory, and every further access to it will be really fast. The same happens also on the EF6. If you utilize EF6, the first access is really slow, as we have seen, the 2 seconds, and the second access to it, it is nearly the same one. So we will get 10 milliseconds, 50 milliseconds, 5 milliseconds. It depends a little bit on the load on my machine. That you can compare that, basically. One thing which has changed a lot in this example is, in this case, we have only added one person. If we adjust the little sample and say, I want to add, for example, 1,000 persons, the code would look like, most of the time, nearly that way. Really sample example. I'm just wrapping the code to insert a person and say, okay, I want to call it 1,000 times. So I'm adding 1,000 persons to this database, and the really execution time will be in the last line, in line 29 here, when I call I want to save all the changes. 1,000 rows we are getting inserted into this database, and with EF core, this one will be really fast. Really fast. We have in this case 1.27 seconds now. That is with initialization time. Pay attention. So we have 1 second to initialize and 27, 25 milliseconds, 250 milliseconds, sorry for that, which is taking time to insert 1,000 rows into this database. If I exchange now this and say I don't want to utilize the core one, I want to utilize the EF6 one, it will be of course slower because initialization time is already in this case much more, and we have in this case 2.7 seconds. So the comparison is already in this case just 1,000 records, already a nice difference. If we further increase the amount and say I want to insert 10,000 rows, for example, I can now already wait a long time with EF6, because that's the area which everyone has already taken and talked about and said EF6 is quite okay if you're working with less amount of data. But in the case you are working with 1,000, 10,000 of data, 100,000 rows of data, EF6 was never really fast. In this case we need 21 seconds, subtract the initialization time, around about 20 seconds with the EF6 version. And just if we switch out and say I want to do the same again with the core version now, we will see that this one is really fast in this case, because 2 seconds for initialization and the insert of all. If you don't have used Entity Framework before, you can ask now the question, why is it slow? What is it doing to be that slow or to be that fast? The answer is really easy. If we just switch again back to the EF6 version, I can enable instance.database.log, and that's a property which you can interact with and set it with a little delegate and say I want to log every SQL statement which is getting sent to the database. And I say I want to trace that SQL and say console white line the SQL statement at all. And I'm executing that again. And executing that again. Cool. We will see that we see nothing. Why? That's quite okay. What does happen here?
Didn't it say fail somewhere?
Yeah, it says it's looking up for the migration history table, but that's quite okay. It doesn't find that because it doesn't existing. But it should do something.
Or is it still waiting for the 10,000 inserts?
Yes, it was waiting. Yeah. That's because the 10,000 is a little bit too much in this case, because that's, The problem is in another area. I'm just decreasing the amount now to 100 just to see the SQL statements at first. The first difference here is with EF6, you will see that for every insert we are doing, for every data row we are creating afterwards, EF6 is creating one SQL statement. It says I want to insert one person. And afterwards I want to insert another person. and another person, and another person. So in this case of 100 persons, I am getting 100 separated statements. And that's clearly not the fastest way to insert many data. EF Core is changing that a lot and say, I want to do that a little bit other. If we change that now and say, I want to, I want to use the DB context core, and I want to log the SQL statements which are getting sent to the database. I'm getting now a little problem here because in the EF Core version we don't have this delegate to just log the SQL statement. I can't say I want to set the log delegate here to some statement, so I can't do that. In this case I could switch in a logger into the entity framework core and say, okay, I want to create a logger which is logged that to the database, to the console, for example. Or otherwise, I can start a profiler. In this case, it is faster for me to just start a profiler because I just wanted to show you that the statement is completely a different one. I'm just creating to the wrong database, the local DB I want to use. Yeah, I'm just starting this example again and say, okay, I want to insert all these persons. I am finished here, so in the profile I would see here the statement. Yes, it is already here. I'm just copying the statement out of it to increase a little bit the font so everyone can see that. Yeah. Entity Framework Core is creating just one statement. In one statement, it is getting inserted, it is inserting 100 persons now to the database. It says, okay, I'm trying to batch as many rows as possible here in one statement. It says, okay, I want to declare here a temporary table. It declares an insert table here with the attributes I want. In this particular case, it is an ID and the position, whatever it is. And with the following values, I'm filling up this temporary table, and afterwards I'm inserting that into the person table. That's this line here. And that's the reason why it is much more faster in comparison to the EF6 version. EF6 has sent 100 single statements to the database. And EF Core is trying to batch that and say, oh, you want to insert many, many rows to the same table, and I sum that up. And I say, okay, it is faster for me to create one large statement and send it to the database once, and afterwards it's already finished. In the case of an MS SQL server, in the case of my configuration, there is naturally a maximum size of the SQL statement. That's already automatically configured. It is depending on how many columns you have for one data set. And the other one is how large and how long the statement itself will grow. Because every database system says, if you send me 10 gigabytes of SQL statements, I'm ignoring that completely because the security not that good. And then you can configure that on your own. Especially in this case of batching, it is not always faster. If you're just inserting 2 rows, for example, it's faster for the SQL server to say, okay, I'm inserting 2 separate rows and not combine that into one batch because the processing of this batch costs me more than 2 simple insert statements, for example. So it depends a little bit on the case. But the feature is a feature which EF6 doesn't support at all. And with EF Core, you get it out of the box and you can say, okay, I want to insert many, many data, many, many rows. You will be much more faster as with the EF6 version. Much more faster in 2 cases, because the one thing is to batch some operations on the SQL side. So that means EF Core is faster in creating the SQL statements in an optimized way. The second thing is, I haven't seen any log entry with the EF6 version as I have done before. because I've written here the 10,000. I haven't seen any output on the console. I just was a little bit confused about that. What is the reason for? The reason for it, EF6, you had to pay attention how you are writing your code and using the API of EF6. In this case, I have several called the add method in a loop. And at every time I'm calling the add method, EF6 has tried to detect, just to be sure, do I have anything to do if someone would call now save changes? It has to check internally the state of every already added entity to this context. That means the first add call is really, really fast. The second one is slightly slower because it has to check, what are the changes? I have already one data set and this is the second one. That one is added, that one is also added. Okay, I have to add two if someone would call save changes now. Again and again and again and again, and with every call it is getting slower, 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 slower. That means with EF6, in this case, most of the time has been spent to the add method and not to the save changes. That's the reason why I haven't seen any output to the console, because EF6 hasn't to do anything with the database. It has just to compute, does anything have been changed in my loop, in my add method. To optimize that, I would have to do that a little bit a different way. I have to create a list, for example, a persons to add list. I have to add this to a list, and afterwards I have to call instance dot persons add range, for example. That would have been a completely legal way to optimize this one with the EF6 feature. That means in EF6 I have to add it to a temporary list and to call add range at least, because at calling it add range it has just to detect the changes only once. Before calling the method I haven't any change, and afterwards I'm adding 10,000 of persons, and afterwards it's getting really, really fast because it just have to loop over this 10,000 persons once. That when in this case I would see the SQL statements much more faster than before. I see that now. You will see already, okay, we are inserting every person for it on its own. So for every person I get one SQL statement. In this case, after 13 seconds it's getting finished, but it's not completely right because the console log will take some time at that. That means that would be a nice comparison now. With the EF core version we had 2 seconds, and with the EF6 version we have 5.7 seconds in this case, which is much, much more faster than before, but in comparison to EF core already much more slower. Just to get that. Just to show you one last thing, because time is running really, really fast for me. What was really hard with the EF6 thing, just to talk about that again. With EF6 I could add a connection string to say I want to connect to a database, and it always tried to connect to an MS SQL database. I could configure that with some hacks, or for example with the app config, to change that and say I want to connect not to an MS SQL server, I want to connect to a Oracle database and a SQLite database or whatever. With EF core it is getting much, much more easy. I have just to create and say, okay, I want another provider, so I'm installing that one per NuGet and say, okay, I want to talk to an Oracle database or for example to a SQLite database, and I just have to call the right method here on configuring. That means I could do it a little bit different. I could do it in that way that I say that's my base context, for example, and say that's my MS SQL context, deriving from the core context and overriding just the onConfiguring method and moving that one here. That means switching some database systems and say, I want to define one context for different databases is really, really easy. I just have, for example, that is one way to do it, derive from my own defined context, which is not database specific, and configuring it specifically for an MS SQL server in the derived class. For this case, I could do that twice and say, okay, that's the MS SQL context, and in this case it is the SQLite context, for example. And I'm not calling use SQL server as a options builder dot use SQLite. If I have installed the provider, which I don't have at the moment, but I could do that really, really easy, and say, okay, I have two different types now to work with, and say, okay, I want to connect to an MS SQL server or to the SQLite database, but with the same model, that it's always a person. And that's really cool to say, I want to have, for example, a local database, which is a file-based database like SQLite, and also I have a remote database, for example, and say, okay, that's an Oracle, MS SQL, or whatever database, and always working with the same context at all. And that's very easy with EF Core. With EF6, that was really, really hard to solve to this problem. Just to get the points here again. Yes. That's for me a really, really important thing to just to mention that again. The database providers which are getting supported by EF Core. That is their list which is supplied by Microsoft. So they are summing up which databases you can use, for example, with EF Core. We have already support for MS SQL, for SQLite, of course. Just to mention that, Microsoft is delivering one additional provider, which is called in-memory, for example. That was also not that easy to solve with EF6. You have always to connect to a real database. In the case of Entity Framework Core, you can utilize and say, I want to use an in-memory provider. That means just a database which is held in memory. Depending on how you are testing your software, how you are writing your tests for the software, you can mock and say, okay, I'm working with a unit of work pattern or whatever, and say, okay, I'm mocking that away. Or in this case of Entity Framework Core, you could have say, I want to do it with an in-memory database, and say for my unit test or for my integration test or whatever, I want to do it with an in-memory database. It is now possible. You get this possibility. But furthermore, you get here a complete list of all the different providers that are not always from the Microsoft team. You see that the first 4 are from Microsoft. Afterwards, they are from different provider like IBM here, or some people which are providing some products for them, like the DevArt one, or a private person like Alex Wiese here for OpenEdge, which is creating a provider for this database system. You can utilize them if you want to. Yeah, if you are working nowadays with EF6 already, I recommend you that you are looking here for the comparison of EF Core to EF6. That's a nice little table, of course, where Microsoft is trying to create a little comparison between the two frameworks. It says, okay, what is possible nowadays with EF6? What is possible nowadays with EF Core? With EF Core, we are already by the version 2.2. That's, in my opinion, a really, really good version, because the some features have been missing in the previous versions, like the first release of EF Core was, in my opinion, useless, because many features weren't supported. Like for me, always a good example was the group by operator. That means if you have utilized EF Core in the first version and you created a query with a group by, the group by is always getting executed in memory on your local machine. And that's not the fastest way. So if you imagine a database table with millions and millions of rows, and you create a group by, and the framework is getting, oh, you want a group by? Okay, I have to catch all the rows from the database, and group by in memory, it's not always the fastest way to do that. It's a possible way, but not always the fastest one. But after all, they have solved also this problem, more or less, and you can use it nowadays very, very good. That's the reason why I want to show you that you can mix it like you want. You can use EF6, you can use EF Core in the same project. You can use it with .NET Framework like we did. You can use it also with .NET Core. It depends on your needs at all. Does someone have any question at this point? Yes? Wait. Oh, no. With microphone, I don't have any questions. Yeah.
So my question was, you pointed at the moment where we have a very slow performance in the Entity Framework 6
Yes.
when you add, because it, as you mentioned, it checks each new entry with the set of entries that were added before.
Yes.
If I'm not mistaken, the initial intent of such mechanism is to get a sort of cache. Let's say you load the data from the database. If I'm not mistaken, the initially entity framework, it takes the data from the database. Every time you consume them, it gives you a copy. But the original data, it's encapsulated in DB context. And it is done in order to have performance effect when you make some edit one time
Yes.
to the item to the collection. Then you edit this item second time, third time. At least how Microsoft described in the source I read, the intention of this is to reduce the number of SQL edit statements it's sent to the server, which is logically because in case if the database is slow for some reasons, if we execute a bunch of SQL, a small bunch, it will be faster. So the idea is sounds okay. As you mentioned, you gave a bright example when this idea works not very good, but the idea is okay initially,
Yep.
right? If I'm not mistaken, Entity Framework allows to disable this feature, which is reasonable in case if you have a simple web application and typically DB context is created just per request, it loads data and it doesn't need to store all the state. So if I'm not mistaken,
You're
there is a
stateless,
possibility
of course.
to disable it. But in stateful applications like web desktop applications,
Yeah.
this feature could be nice. For sure, not in this example, as you showed. So my question is this feature of caching present in Entity Framework Core? It
Yeah.
sounds logically because, if I'm not mistaken, in .NET Core 3, they bring ability to develop desktop application. So
Yeah.
it could be logical to have
But
it there.
it is available in both versions.
Mhm.
This is local cache
Mhm.
you are mentioning.
Mhm.
But what is it about? Is it about you are throwing in a person, for example, with the ID 42? Let's assume this is the person with the ID 42. And you are not instantly saving this person to the database. And afterwards, you are creating a query where you say, I want to get all persons where the ID is lower than 100. Then this result set would include the person with the ID 42. You have already inserted that into this local DB context. So if EF Core or EF6 in this example checks your local cache, your local context, if this entity with this primary key already exists in memory and it's not creating it again. And that's the case in EF6 and in EF Core. That's in both versions the same. It's not depending on the add or add range method also. This is just an internal mechanism. but this caching is available. So if you have did this before and used this before in a stateful application, like you mentioned in Windows Forms or WPF applications, that's still the case with the EF Core version.
Okay, thank you.
Yeah.
Thank you. I have a few notes and questions and observe. So I haven't used ND framework for 4 years or so, and I do see some changes here, and yeah. So I just wanted to add into the previous question that the property name is called auto detect changes, right? So you can basically play with it and enable and disable first level cache. Also have a question about this performance experiment you did. I noticed that EF6 creates a migration table by default, right? This some time could be spent for this, which is not really the case for EF Core. And my question here is: does EF Core support migrations?
Yes, it does. It does. It does support migrations in a little different way than it has been done in the EF Core, EF6 version. Migrations have improved in the feature set because EF6. Well, let's start a little bit different. What is a migration? A migration is a snapshot of the database schema you are creating with your model. EF6 already supported it. That means I could have added a migration for my DB context I have created. In this case, nevertheless, if you use EF Core or EF6, the migration would say, okay, the snapshot describes the first migration, describes to create this database. I have to create a table person. That's the first migration. What's the purpose of the migration? If I'm changing my model afterwards, for example, 2 weeks after I have created the model and the code and the database, I'm coming to the idea, I want to add to the person the city where the person is living. Then the schema and the model are not compatible anymore, because on the database the column for the city is missing. In the case you are utilizing migrations, you can create a new migration, say I want to add a migration now. So and that's the little difference. In EF6, EF6 framework said, okay, to create a new migration I have to do 2 things. I have to connect to the database, I have to look up the schema on the database and compare it to the code which is currently in developing on your machine. It's creating your delta and say, okay, on the database I have a column, it is named first name and last name, I don't have the column city, and therefore I'm creating a migration and say, okay, to apply this migration I have to create a SQL statement for alter this table, I want to add a new column city. So it's always comparing the local code model to the currently configured database. EF Core is changing it a little bit because this model has some, I would say not that benefit if you are developing in a team. EF Core says, we changed it. We are not going to query the database anymore. We quit with that. Instead, we are creating a snapshot of the expected model in the code. So there is one code file which is always describing the latest model on the database and the code model, and this one hasn't to be matched to that. So if you add a new migration with EF Core, it is always creating and computing the delta between the code model, which is in your code, and the further snapshot of the previous applied migrations. And it's always in code, never with a physical connection to any database. And that has changed completely. That's one of the largest differences between EF6 and EF Core. And in addition, what I really like is EF6 wasn't, not that powerful if you want to configure the migrations a little bit more. With EF Core, you can, for example, say, I want to create a complete SQL statement, a SQL script, for creating, for example, the database from scratch. That means from the first migration to the latest migration, a complete SQL statement. SQL script with different SQL statements, of course. You can create that normally. That means create table X, create table Y, create table Z. You can also create an idempotent script. That means a script which is always checking, does this table already exists? Okay, I don't have to create it. Does this column exist? I don't have to apply it. Does it not exist? I am creating this. So this is a script which I can rerun as often as I want to. If it's missing something, it is getting to apply the script. Otherwise, everything is fine. And the last thing which I really, really like is you don't have to create the script always from the scratch to the end. You can always say, I want just a migration script from, for example, the third migration to the fifth migration. And you just create a SQL script for this little part out of all migrations. And all these little things are not that possible with EF6, but with EF Core much more. Okay?
Okay. A few more questions, if it's okay. Regarding bulk insert.
Yes.
I do remember that there is a bulk insert method in EF6. Maybe it's some extension method or some additional NuGet package. It's probably not so
point, yes.
sophisticated as save changes, but there is an option to actually insert it in bulk. Do you probably have some also results of performance with other ORMs like in Hibernate or I don't know?
No,
others?
no,
Okay.
not at all. But just to mention that the bulk insert option is also in EF Core, an additional NuGet package. You have to install it, you get an extension method, and afterwards you can utilize the bulk insert.
Yeah. Okay. And about features, for example, cross database requesting, or I don't know, second level cache, NoSQL engines, something is here, or it's not really supported?
It's already here because, for example, the newest provider, for example, for Entity Framework Core is the Cosmos DB database
so they
provider.
do support NoSQL.
So you have a NoSQL database
Perfect.
provider, which you can utilize with Entity Framework Core. Entity Framework 6 was always relational and only relational. EF Core says it could be relational, it could also be a NoSQL database, for example.
Yeah, and the last one regarding interception. So is there an option to get into the middle of the process of managing entities and intercept the process somewhere in between?
It depends on what point of interception you want. In EF6 you have just one intercept point. Basically you could hook up to the save changes event. Okay, that would be possible. And which was a new feature in the EF6 version, was you can intercept the commands which are getting sent to the database. That means the DB command execution of execute scalar, execute reader, execute non-query, and so on. With EF Core, you get much more points to intercept every point. If you look at the code, it is much more cleaner designed and developed. You get for everything, you get just an interface. You get always some interception. You get a dependency injection supported across over the whole thing. So you can also change the creation of the entities. In EF6, it wasn't possible to, for example, create a constructor for my entity. It wasn't possible. In that point, I have created a constructor with some parameters. The constructor failed. With no parameters, that would be possible, but with 1 or 2 or 3 parameters, it wasn't possible. With EF Core, you can do that. You can say, I want to have some parameters in this constructor. I want to use dependency injection in an entity. If that's a good idea, it's not a question, but it's possible now. Okay.
Without knowing the features in detail, would you say there are still some reasons to even use Entity Framework 6, like features that are not available in Core?
It depends on your needs. It depends on your needs. For example, if you have many views, if you have many stored procedures, for example, I don't know if you have already a project which is using EF6, which is maybe using the EDMX, which is not supported in EF Core at all. It depends a little bit what your needs are concrete, I would say. If you're a classical developer and say, okay, I have a really, normal database with, I don't know, 300 tables, for example, a little navigation between these tables with some joins and so on, some normal things, I would recommend to use nowadays the EF Core version. There is no need to utilize nowadays the EF6 version, which is, in my opinion, a dead one.
So out of your personal experience, you would
Yeah.
say that there are not many reasons to
No.
stick to
No.
EF6 anymore.
As every framework, it is at some point not that funny with it. If you have some things which are not working like expected, for example, but that is also in EF6 the case. We have already seen it, 10,000 entries we want to add. Every called add has cost some performance. You have to know that, otherwise you will say, okay, what's the problem with the framework? Yeah, you have to analyze that once in your life, and afterwards you know, okay, if I'm calling the add method once again and once again, I have to add range, I have to detect changes to disable this feature, for example. If you know that every time, every framework is getting better over time.
Okay, thank you.
Hi. Maybe related to the previous question, I found on the feature list that table per type and things like that are not yet supported. So maybe if you have to migrate an existing application, then you have a hard time.
That's then the edge cases where I say, okay, it's a little special use cases, because not every database says, okay, I have an inheritance in the database abstracted, and then it depends in which type is how it is modeled in the database, and that's dependent on which framework you can use in this case.
Are there more such features that are still missing in Entity Framework Core?
That's the most known one, I would say. If you want to know it concretely on your case, I would just look up the table, because that's really the best one to say, okay, that's the topic where you say, okay, what do I want to use? What do I need? And afterwards I could make a decision for that. Otherwise, yeah, I could say maybe. That's the best answer.
Okay, thank you.
Other questions?
If I'm not mistaken, there is like a list of conventions in Entity Framework 6.
Yep.
According to how I remember. Let's say if you want to recognize some relation between the entities, like many-to-many, you need to use such approach to define properties there, like navigation properties in one entity, and let's say for foreign key, some entity ID properties in another entity. So such conventions, in my opinion, they assume having some knowledge.
Yep.
I mean, if you need to start work from scratch, like it was in my example, and I started to figure out how to organize this, so people spend time on it, they became more knowledge. So my question is, what is your experience with Entity Framework, or does these conventions mostly are the same or no? What does it
Yes.
go?
I would say that are the same. One question furthermore?
For me, when I use Entity Framework, either version, for me, I think the database is treated just as a dump storage.
Yes.
And for me, the problem is, especially when you use SQL Server, you have so many features in it, and also security-wise, I normally would say, no, there's a borderline I have to protect by security, by access, by the data integrity, which is now all pushed into the code. So I leave this completely open. So when would you say it would be better not to use Entity Framework and rather use the stored procedures and everything else that's in SQL Server?
It's a question of religion, I would say. Because many people say, I want to utilize a database just as a storage. I don't want to have any logic in a thing in a database. I don't want to have any trigger, any stored procedure, and so on. And there are other people which are saying, I want to do as much computation in the database because the fastest way. And that's really, really hard to say because, for example, if you have a web shop with 100 articles, it is faster with a stored procedure. Yes, it would be faster, but it is really worth the effort for that? I would say no. But if you say, okay, I have in this database, I don't know, per day 10 million rows of data which have to be analyzed and to sum up with a data warehouse, for example, the stored procedure would be a good idea in this case, for example. It really depends. I think you can't generalize an answer for this question.
But how much support do we have in Entity Framework Core if I do a lot of things in the database already?
Less.
Less.
It is clearly concentrating the logic, or logic is relative, the mechanism, how data is getting queried and inserted into the code.
Okay.
Especially if you, for example, are very fine-tuning your queries, you get very less possibilities to interact with the query itself, which is getting sent to the database. Normally, you don't getting interested into that. You say, I just want to get the data, give it to me. So you are concentrating more on the simple things, I would say.
I say, if it works, I'm not interested.
If it works, you don't.
Which is not the practical part.
We are talking about the 10% where you say it doesn't work like expected. Yes.
Because when I saw before, when you created the persons table,
Yep.
and I saw, wow, varchar max, not a good idea.
Not a good idea. From a performance perspective, it's not a good idea, varchar max, for that to use. So you have to know that. On the one side, you have to know that. On the second side, you have to configure it. And you have only one chance to configure that in the code. Because I'm creating it out from the code, so I have to configure the max length of the property first time and last time and say, no, I want to optimize that from a perspective of a database and say, in varchar max is not the best option. I want to say max length is, for example, 100 characters to get it, and I have to write that in the code behind. So I have to know that on a database level. Yeah. So it's concentrating all the things down to the developer. It is a fact. Any further questions?
Okay.
Okay.